welcome to another That's Just video. This is That Man Who Laughs, and today I'm going to talk to you about data analysis. Well, not just data analysis and all its different flavors. But before that, I have a question. When you want to answer a question, what do you do? What do you need? To answer questions, you need information, data, info. You need expertise about the stuff you're trying to answer. Like if I ask you about quantum physics and you don't have the expertise, you're either lying, quoting Google, or just saying, I don't know. And then what's the next thing that you need? You need an analytical mind. So you can analyze things about the data using your expertise. Right? Okay. And do you need anything else? You need mindset. You need mindset to have a mindset about that question. So what is data analysis? Comes into play in answering questions. In business, we always have questions that we're constantly asking. Like, remember the one that I told you? How can we provide our customers one in a way that aligns with their value so that we are demanded? That's what we talked about, and about the needs, wants, and values in the video called Black Box of Marketing. Remember that, and you can see it up there or there. I gave up on this already. Everybody makes this mistake. Even Markiplier made this mistake once, because you see, you look at your recording, and it comes up this way, but then it gets mirrored, so it comes up this way, this place, and you have to do this. It's like as you're talking. Anyway, so we keep asking questions, and we keep striving to answer them when it comes to business. Data analysis is the analysis part of the answering process. Okay, we used to do it ourselves. We still do it ourselves a lot of the time. But since we have a lot of data right now, like the data that we have right now is so much more, staggeringly more than what we used to have in like 10 years ago. And the data entry points, like the data points that they keep, that we can gather data, are becoming more and more diverse, and that's why we need data analysis. The data itself is getting bigger. The data entry points to where data comes in is getting more and more diverse, like the smartwatches. Like imagine you want to gather data from people's health, and stuff like that. You have a product that does health stuff, let's say. You used to just ask people about their weight and height and stuff, and BMI and stuff, and that would be it. But now you can also track their data using their smartwatch. That's a new data point. That's a data entry point for you. And all these new technologies lead to more and more demand for data analysis. Because before, like when you were working in an organization or like in an office, you would just take your data and you would go to the Excel with and ask them, hey, I emailed you something, I cannot figure this out, can you help me? But now the data is too much, and there are a lot of different types of it. So we have to rely on data analysts to figure these things out for us. And since more and more smart systems came in, became more and more live. So more APIs to call, more live data to call. Instead of just emailing data back and forth, we're downloading it or streaming data live, and that's more of a data analyst job. But that comes with its own problems because data analysts are masters of data analytics. They're not good at what you're doing. So you have to understand them, and they have to understand you and your requirements. So there's a lot of uh, stuff that you learn when you try to learn to be a data analyst that it has to do with understanding your stakeholders. Go watch the video about stakeholder analysis. Understand the people that you're working with, understand the process of the project, especially if you're a business analyst. It's basically data analyst plus project manager. It's the business flavor of data analyst. It's the business analyst. That's it. You need to understand project language when you want to analyze businesses or analyze data for that part, and also DevOps and data ops. Because as I said, data entry points, multiple data entry points, and they have to be all monitored and managed. And the IT is sometimes not enough. So you sometimes need to learn data ops so you can engineer your data entry and all the other stuff. I'm not getting into that today. Today we are talking about um, BA with a basically mostly tell. Today is mostly tell, mostly show. Sorry. You see less and less of me, more and more of the project that I have done before. And these projects are really basic. Again, to be, honest, they're basic. But very basic compared to what I've done before. But they're not basic at all. They're really good. At least they can show you how things will look like. Yeah, so the first thing that we're going to tackle is business analyst. Business analysts, as I told you, they're like the business flavor of data analysts. They do less data analytics work and more business work that has something to do with data analytics. If you can make a business case, if you can write a successful business case and analyze all the things that has something to do with this, you're a great business analyst. You're a good business analyst, and you can pat yourself on the back. The next flavor of data analyst is market analyst. Marketing plus data analytics. You learn Google Ads, you learn Facebook Ads, you learn marketing if you are a data analyst. And there you go, you're a market analyst. Or you are a marketer, you learn data analytics, there you go, you're a market analyst now. The other one is financial analyst, which is financial jargon plus data analytics. Financial analysis and financial reports on their own, they are data analysis stuff without the added, data stuff. I don't even go there today. That's a different video on itself. The last one would be BI. What is BI? So when you do the data analysis and all the stuff that we do, you use the awesome framework, which is um, obtain data, scrub data, search for trends within your data, model the trends that you search in your data, then interpret your data so that others can also understand what you understood from your data. Use BI. Reports more and more are becoming live reports. Like before, you made a report and you just send it, email. That's it. Now you share a link. Because guess what? When you write stuff and you send it to someone, they let AI read it. Your writing parts are being done by AI. You do it by AI. They read it by AI. So mostly you're just making AI read for you or write for you. The important bits are the data that you're trying to show, the visual, the things that you're trying to visualize. And they more and more have live entry points, live data entry points. So the data keeps changing. And as a result, your reports have to keep changing. So you end up, I realized that myself that more and more I'm just sending links instead of sending, Word um, files or Excel files. I'm just sending links now, mostly. That's BI. And as a BI, you need to understand, again, the BA stuff. You need to understand the DA stuff. You need to understand your stakeholders. You need to understand the project, the question that they're asking you. You need to gain that insight and try to peer into their mindset, the mindset of the one that is asking you the question, so you can ask the data lake for them. That's it. Now let's get into BA. I'm going to show you the different components of a business case, and after that we're diving deep into a project capstone that I did for BA, and after that the projects that I done for data analyst, market analyst, and uh, end it all with a BI reports that I made. You. Aside from data analysis, a business analyst needs to know how to write a business case. Now, a business case includes a bunch of stuff, and you need to learn a lot of different tools and know how to use them. The first part of the business case is the executive summary. Then comes the introduction. Then the business objectives. These are obvious, I'm just glancing over them. And option analysis and solution recommendation. What options do we have? What solutions do we have? In here, you can use bow tie analysis. I'm getting ahead of myself. Let's keep going. Capability assessment, which is a baby internal analysis. Go watch the video if you want to learn that. And to accomplish this, we need impact analysis. Again, as you move, you change, and that change changes stuff. So you want to plan something, you need to plan for where you end up as you're moving within your, you know, um, milestone. So you end up having to analyze the impact that you make as you are moving through your plans. It's not just how the environment is affecting you, it's also about how you are affecting the environment. How do we do that? How do we analyze the impact and do impact analysis? We use the puppet model, which stands for people, organization, processes, information, and technologies. And also the gap analysis, which is current state versus your desired state and the gap between them. And you turn the gap into key milestones, and those milestones help you develop action plans. Here's an example puppet analysis for something that I did within the course, and don't ask me, I don't remember it. This is really basic, and also it's not correct. But as I said, when you're trying to, you know, exercise and try things out, you're not actually analyzing stuff. So in here, it's like process, current state, and the future state. This is the extent of gap analysis. But as I said before, you need to uh, not just analyze where you are and where you will end up, but also analyze the gap between them and come up with milestones and action plans. So this is not a gap analysis, but this is a very, very beginning of it. You see the current state, the to be state. There, you just set the current and to be state here. But that's not enough of a gap analysis, and this is not enough for the process part of the puppet. But anyway, you have organization, again, current state, to be state, people, stakeholders involved, skills required, impact, information, again, as is, to be, technology, as is, again, and to be. This is kind of it when it comes to, a project like this, but again, just an example. Also, you need financial analysis, and I told you, and I'm telling you again, this needs its own video and own explanation. It can get really, really deep. Then we have risk analysis and risk assessment. It's baby resilience analysis. You go watch the video about resilience analysis. There are surprisingly a lot of different tools for risk analysis because, well, they're important. But basically, once you understand and analyze the outside opportunities and threats from your SWOT, after your external analysis, go watch the video, you find things that can be of risk to you. And here, this is called the risk analysis matrix. It's basically how bad the consequences might be versus how likely it is to happen. Like you say, oh, I might stub my toe. It's highly unlikely that I will stub my toe. No, it's actually really probable that I will stub my toe. Okay, how bad the consequences is? It is intolerable. Then it comes here. There. Then we have Monte Carlo simulation. So Monte Carlo simulation is a statistical method, and we use it in project management, we use it in risk analysis, we use it in financial analysis, and not just these two, because it's a statistical method, we even use it in engineering. So how does it work? Instead of relying on a single point estimate, like saying, oh, this project will take 90 days, we simulate and model thousands of possible outcomes, not thousands, a bunch of outcomes, basically, based on varying input variables like, I don't know, cost, duration, and resource availability, and other wildcards that might affect our project. And each run uses random sampling to account for uncertainties. Basically, you have a bunch of variables, and for each of them, you just assume some of them, most of them, as a constant, and you pick one and you use that one as a variable. That allows you to solve a single point calculus thing instead of a multiple variable uh, math equation, which is really hard to do. And you end up with a lot of different results for a lot of different situations. Why do we use it for risk analysis? Well, it identifies probable project completion dates. Like, instead of saying the 90 days, you say like, oh, Monte Carlo shows us a 70% chance of finishing within 95 days and a 90% chance of finishing within 105 days. We can predict cost overturns, like helps assess how likely the project is to exceed budget by analyzing possible expense fluctuations, or we evaluate impact of risk factors. Like, instead of assuming fixed delays, Monte Carlo simulates multiple risk scenarios, showing how one delay or a delay in one task can affect the overall timeline. Or we can use it to support decision making by providing probability-based risk assessment, basically helping management make data-driven decisions instead of relying on simple intuition. An example would be, again, like, imagine a software development project with uncertain coding time and testing delays. Instead of assuming fixed completion time, we run scenarios and we show the probability of each scenario, and the ones with the highest probability, we pick them and take them for granted and say that, oh, these are the most likely things to happen, and we prepare for them. And the good thing is we can actually, based on math, see our most risky things that we need to prepare for, and this helps us with that. But I'm not going any deeper into this Monte Carlo model, because you can get very deep with this one. It can very well be a video on its own. It's quite substantial. Then we have Swift. The Swift method, or structured what if technique, is the next thing that we can use for risk assessment, which is just exactly like that. Ask, what if this happened? What if I stub my toe? The answer, you will perish. The likelihood of me stubbing my toe, very high. The severity of it, really severe, like you wouldn't imagine. And recommendations, skill issue, fix it. And then the next one, and then you keep going, next one, next one. Then we have the bow tie analysis, which I said can also help with finding out threats and frequencies. And we have the fishbone. Fishbone is the other way around. Basically, you're reverse engineering to, oh, this happened. How did we get here? No, why did this happen? You go from effect to cause. You're going backward. You're reverse engineering it, and you find that, oh, it could happen because of option one. It could happen because of option two. It could happen because of option three, and you keep going back and going back and back and back until you find the root cause of why this thing happened. You can also use this for a hypothetical scenario. Like, you imagine that the worst case scenario happened and you go back and you find the most likely cause of why that thing uh, might happen. Also, there's the Delphi technique, so I forgot to mention. Then we have the implementation plan. Um, you write it down, or you have a mind map or a UML for it. Then we have the project monitoring and evaluation part, which has requirement documents or RecDoc, requirement categorization or RecCat, user stories, UML, BAM, again, UML, Unified Model Language. BAM is Business Activity Monitoring, and Invest Model, which was this, basically. Independent, negotiable, variable, estimatable, small, testable. Is it like you have a requirement and you use this to give it a like INVEST. And also there's requirement validation and verification, and then the conclusion. So let's look at a project. Okay, this is the requirement part. We want some features done in a product. We want contact management, we want sales opportunity tracking, reporting and analysis. These are the features that we want. So we want to um, categorize, document our requirements for these features that we want in our project. And we write down the requirements and we give them IDs. It is important to give them IDs. It is, yes, you need to track them. So you cannot keep writing this whole thing in your table, tracking table. We use this one instead. And this one has like two for each, but it's not like this. One feature can have 10 requirements or have one or none at all, because it's not required. There is no requirement. It it actually exists on its own, or it will exist once the others exist already. You get it. So you take the requirements for the features and you turn them into epics. And then again, you give your epics IDs because you want to track them. I didn't do this. I just use these as user stories. Not these, but I made user stories for these because they were small. These features were small. And here are the user stories. Again, ID code them. Title of the user story description, and you see the as a I want so that we talked about in the product owner video deeply. It is important. This is how you write a user story. go watch that video if you want to learn more. And an acceptance criteria. Given, when, then. Given I am logging into the CRM system, yada, 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 when I navigate to the yada, 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 then I should see a yada, yada, yada. You write it like this for each and every one of these. Ignore that they don't have it. Because the given and when is basically the same for all of them. And they have IDs, okay? It's important and paramount that you keep getting them IDs. Then you make a roadmap based on the milestone. Remember, the gap analysis and milestones come here. They come here. Then you guess a duration or get a duration, and like you ask the experts about it, and they will tell you like, oh, this will take 20 days. Base it on weeks, and this is the basis of your Gantt chart. Then you have a Gantt chart. Yay! So reference them by the IDs that I kept talking about. ID them. It's important. So this is an epic days or the user story, and you see this epic takes 3 days. Yeah, this one takes 3 days. Remember that 20-day thing in here? It's this. And under it is these. The first one takes 3 days to finish, and you break that down. There. It is broken down to tasks. Then these tasks have responsible people. Again, duration. You have to analyze the dependencies. Like you might understand like, oh, these cannot be done unless we do the UX design first. Like Lisa can only start working after Rachel finished. Then we put the times in for each task, and some tasks can happen, in tandem. And then we go to the next and the next and the next. Now, this looks like a waterfall. See? It's falling and it's blue. This is why they call this the waterfall approach. So in projects, you usually either do the waterfall approach or you go agile and scrum. Agile is like, okay, everything is changing, and constantly iterating is agile. The more you're working with external elements, the more unstable your environment is, the more you go towards agile methodologies. But for internal stuff, which business analysts mostly focus on, and project managers and product owners, at least on internal products, focus on, you use the waterfall approach as much as you can because it's controllable, it's easy to track, you can ID everything, you can formulate everything, you know what's going on, you know what's going to happen, and you like this. But still, you see elements of agile coming in like sprints. Instead of calling them like 2 weeks, we just call them sprint 1, sprint 2. Knowing full well we are not doing agile. We are not doing agile. This is literally a waterfall process. But who said we couldn't take in good things from other modules? We're taking sprints, user stories, acceptance criteria, all of them from the agile methodology, and we're using it here, which is actually real, which is true. We do this. We actually do this. Anyway, now all those IDs come in clutch. Here we have our IDs. This could just be a list of IDs and a bunch of comments. So this requirement has these user stories, and these user stories have these tasks related to them, and these tasks have these tests related to them. And then you test them or give them to the tester, and they write their comments for you, and they give you feedback. They say, oh, everything works except for AC0904. And then you can track down AC0904 to which task, to which user story, to which epic, to which requirement, all the way back. And you can plan everything again according to that. It is imperative, it is really important to have this traceability matrix when you're doing Gantt chart, because this will never happen, almost never happen, because you know what? What if Mark stubs his toe and misses half a day? Then we are pushing into this task, which are pushing into other tasks all along the way. You see, this is the problem with waterfall code. Now, traceability matrix is really important. You want to keep your Gantt chart updated. If your Kanban is your control panel when you're doing product ownership, in project management, this Gantt chart is your house, basically. This is your kingdom. But business analysis is not just about, writing reports and analyzing stuff. It's also about analyzing data, which means you need to know the pivot tables. Pivot tables. Pivot tables. Lots of pivot tables. Pivot tables for pay. Pivot tables. Truth. Another example. Pivot table. Yep. So you saw this was more project management than data analysis. I hear you. Business analysis is not just about, filing reports and writing a business case. Yes, you still have to do a lot of analysis stuff. But I'm getting there. Next up, we are looking at some projects that I've done in Excel and SQL. Honestly, I use SQL and Excel way more than Python anyway. If I had to tell you which tool you need most as a data analyst, at least as a business analyst, is Excel and SQL. And it's getting more and more to be SQL because data is becoming more and more bigger. Okay, now let's take a look at this in Google Sheets. We have our data set here, and then I of course changed it for myself. I added a total here, which is product of price and quantity and at a time, which is why? Because this is just for one day, and if I want to, you know, make a timeline for it, I have to do it based on hours. And I made a bunch of scatter plots, and this was the one that survived. This is the last one. Okay, so you begin your journey through autumn. This is the awesome framework. You obtain your data, you scrub it, then you explore to find and figure out if there are any trends in within them, and then you model based on the trends that you explored and found, and then you interpret your models. You put them in a report or a BI or whatever to show it to others, interpret it for others. Now, back on this. We obtained our data and now we are scrubbing it. We want to scrub it, but we cannot because we don't have access to the owner of the data, so we cannot ask them like, what the hell is this? Why are they codes in here, but these codes have letters in Y? I don't know what these are, so I cannot confidently delete them. We have a lot of discrepancy with these. Yeah. Anyway, let's see what I did. You can write SQL in Google Sheets, and I told you before, you can just write equal query, and then you can write SQL. This is your data set. This is really similar to, this is basically SQLite. So yeah, this is SQLite, except for this. You see the header ID, the identifier ID, you're using these A, B, C, D, E, F, these ones. But your data doesn't come like this. It's not A, this, B, and then your data, it doesn't come like that. It's basically like this. Invoices, the code, the descriptions. So when you try to write the stuff, like in this case, F is price. You write price less than 5 and price more than 1, order by price, descending limit 5. Show the top 5 of the orders. That had prices between $1 and $5. Why did I choose 1 and 5? And why not 1 and 3? Huh. Yeah. This is the sending. It starts from 1, goes up to 5. This one comes down from 5 to 1. And what do I do here? Select A, C, F, and D times F. Quantity times price. The total. And H, country, where A equals this one. Oh. That's right. I thought this was related to this. This is another one. This is the average. What is the average quantity? Smart. Nice. This is the average quantity. What is it? Yeah, I didn't take mean of quantity. Right? I just took mode and median. Okay. What I do here? Oh, description, minimum price, maximum price, average price, price quantity, count description. Uh, I wanted to group the description and find out the popular SKUs. Why did I think that the price would be different? Most likely I just copy pasted this. I changed it. What the hell is this? Why is this zero? And why do we have one order for this? What is this? This is why you need to scrub your data. Like we cannot because we don't have access to the data owner. And here, what did I do? I select the country, sum of I can just read these and guess. Sum quantity, min price, max price, average price, product of yeah, total and count how many orders we have in countries. Okay, how? How? We have 18 orders from Australia, averaging $4.25, and they bought nothing. You see, the data is really problematic. We only have one customer from Belgium, and they were rich, and one customer from USA, and they were rich. What are we selling even? Pencil egg house? USB glare lamp? What is 12 ass zinc? I shouldn't keep reading this for a video, no. Okay. Oh, you're selling mostly in UK. Most likely this business is based in UK. What the hell? What the hell? Did the UK colonize this business or something? How are they buying stuff for nothing? How? There is a. This means there is an order here where some guy bought something for nothing. And the guys in Australia are making up for this by paying us for nothing. These guys are Australians are paying us for nothing, and UK is just picking things up for nothing. How is this happening? The data is a mess. God damn it! So we select everything where H contains G. What is it? Country. I wanted to see Germany, basically. I think. How many are they? 44. Yeah, can take a look at this again. Empty ones. But if I delete these, you see, like I might lose all the sales that have this 595 price point. Apparently, yes. So you see, you need access to the data owner so you can clarify things like this. You have empty invoices that don't have code. What is this? Oh, I picked a random SKU and ordered by the user's coordinate. What is -1? What is -1 purchase? Did they sell us stuff? If they did, then why is the same SKU? I mean, look, you see this? We don't buy something for 4.95 and then sell the exact same thing for exactly 4.95. We don't even take returns like this. Returns, like, this could be return, I guess. I mean, this data is an example, but so yeah, these things, customer ID, that the customer doesn't exist. Oh, again. Holy God, this is an invoice, actual invoice, and we purchased stuff from UK for nothing. There was this really, really unknown gentleman or gentlewoman who gave us 240 shorts for nothing. Or whatever the hell this is. At least this makes sense. You make a different SKU for purchase, but no purchase price. These came to you for nothing. Oh, wait a minute. Wait a minute. Wait a minute. If the purchase and sales are in the same place, it should be zero. It's not. Whatever you do, don't be like this person. Don't enter data like this person. No. It is seriously problematic. Like I even began, yeah, you can tell. This is my statistic analysis. I wanted to do a statistical analysis and I just gave up. You see, just this and then I just gave up because I, you cannot. Like, you see this in front of your face and no, this, you see this and you call them like, hey, yo, what is this? My friend, what is this? Explain this to me. Why do you have minus quantity purchases? What is this? Explain. You know? And why is there an eerie within the countries and there isn't one? How? What is what's that? Anyway, let's go through actual data set. This is the market data from CoinGecko. Now this we are I obtained it through CoinGecko API. You go and sign up, you get an API key, and you set up like so. You come here to extension, and you get an API connector. You open it up, whoop, and it comes up like this. Then you put create. The rest of it should look like this. Oh, yeah. This. You pick CoinGecko on your application. You get your API key, and you put your key in here. You choose your endpoint, like what you want. You want a coin. You want the historical data. You want your market data. What I showed you was market data. And then you pick your the currency you want your data to be against, and some other parameters that you can choose here. It depends on what you pick in here, your input. Then you choose your destination sheet. It's almost always at a one of the sheet that you are, which is sheet 1 in this case. What do I do here? Select all where the symbol contains X, and R, which is okay. Numbers PQR max supply. Max supply is less than one. What? Why? Ah, that doesn't have a max supply. Order them by X. What is X? X is all day. Yeah, the day they were introduced into CoinGecko database. Or the day they were open. So why X? Let's try B. Let's see if we can see Bitcoin. Do you see? I don't. Oh, Bitcoin has the maximum supply. That's why you're not seeing it here. Okay. What do I do here? Pick the and current price times total volume. Order them by the time they were introduced into the market. Yeah, I want to make a historical price graph based on all the available total volume times the price. But it shouldn't be current price. It should have been price at the beginning for it to be a correct representation of how cryptocurrency market grew. That's why you see jumps like this, shift like this, because some cryptocurrencies jumped a lot. Yeah, they have increased a lot of value since the day they got introduced. Also, the total volume in here is wrong because that's not the available volume in the market. But you can argue that this is correct, like the total market, total volume in the market, and the price at basically this date, this time. So this is the thing that they gave us. And what is this? Yeah, I made this one. This is cumulative sum of all of these. Yeah, yeah. I call it all dollar. Hmm. No, yeah, the historical market cap basically. It's wrong except for this point, but it gives you a representation. What I do here, what was our supply, maximum supply. Yeah, the ones that have a maximum supply, and again, sort them based by this. Okay. As I said, awesome framework is this basically: obtain, scrub, explore, model, interpret. You obtain your data from wherever. You call them from APIs. You call them from your internal domain. You scrub them. You get rid of irrelevant data, data that is way out there, or corrupted data or bad data entries. Then you explore to find trends and interesting things about your data. Then you model them based on the things that you found. Oh, this is what this is the behavior of my data. Now I'm gonna model to find out what it's going to end up looking like. Or you do a regression, you have an endpoint and a beginning, and you want to find what's happening in the middle, or you want to go back in your data, what happened before. Basically, you have a data deficit that you want to cover it up. You use modeling to find out what is happening in that bald spot. Then comes interpret, which is interpreting your uh, findings so that other people can also understand them. Here's a SQL syntax. Really simple, isn't it? Really simple. It's just one page. It's easy, simple. SQL is really easy. You just have to play with it. Again, just play with it. Just play with SQL a bit. It's a good kid. SQL is a good kid. It got, it, it got hard, man. It's good. It's cool. SQL is for the cool kids. Yeah. Don't let them tell you anything else. They lying. SQL is cool. See, it's easy. You need to think a bit harder for this before to use SQL. You can see it. Like it's the functions and everything is really limited, but uh, on the other hand, you can work with a lot of data. You're way limited in what you can do with the data you have, but you can play with a, a lot of data, like an ungodly amount of data. And that's fine. Now, next up, we have Python. Yeah, Python. Because we have bigger and bigger data sets coming our way, we need a tool that can read bigger and bigger, more and more data. And because the data entry points are becoming more and more vast, we cannot usually work with SQL. Like personally, I use Python mostly to unify our data to one singular shape, so then I can use SQL on it. That's what I use, what I do personally. But more and more, I'm seeing the benefits of Python. Again, I have rarely used it. I know it. I forced myself to use it. I forced myself to learn it. And I hate myself for it because AI is a thing. And AI is good. when it comes to analytics stuff, it's good. Like you might not be able to code a 3D game with AI. Oh no, you can't. That's really hard. But when it comes to data analysis, it's more here, more you know, on the analytic analysis part of your brain than the coding bit and the coding knowledge. Look, we there was this project that we did. We kind of had backdoor access to all the cashier data points in the country. I know, kind of illegal. Yes, the company that I work for bought the only company that provided cashiers. You know, the ones that go boop, boop, next. You know, the read QR codes and stuff like that. So we had all the data in the country. The size was immense, and we only used SQL for it. But we could do that. We could get away with that because the data shape was similar. The data shape was the same basically. They were all giving the same, outputting the same data. But when we're talking about different data types and different data entry and output, then yeah, you might absolutely need Python and pandas. Welcome to Python. First of all, this is Jupyter Notebook within Python. I use Jupyter because, like, when you run code in Python, it's like you run 2 plus 2, run it. Invalid syntax is 2 plus 2, goddammit, run it. 4. You see, your answer comes down here. But when you're analyzing stuff, you want your answer to be close because, like, look at here. Holy God! Oh, yeah. So it gives your answer right here. So then you go to the next one. So you're analyzing stuff and you want to go back to what you analyzed before and check for discrepancies. This is helpful. Check for, things that changed. So here, install CoinGecko, yeah. What is this? Import CoinGecko and import pandas. Don't get mad, this is the basic joke that everyone, every data analyst makes at some point in their life. I swear. We always import pandas as PD. Why do I have so many comments? I fed this to AI. Either AI did this or I fed this to AI. Yeah, I did definitely send it to AI. Look at this. I don't write like this. I'm gonna guess. I wrote this part. I didn't write this. It didn't work. I put it through AI and it fixed it for me. Because I didn't know what it would include for, so I could take my test. Or I could get a price of Bitcoin. The infamous DAF problem. When you're making a data frame, just always name it. Always name your data frame. Because it will be rewritten. You keep making data frames all the time. This one is definitely rewriting. Like if I say the display DF down there, it will not show this. Or it might, because I named everything else. Huh. Let's see what I did here. Coin market versus USD. Market cap this. This is wrong. But you can give me a. Yeah, this was not wrong. Oh, I remember this. I had to input all these. Like you didn't have to write these. These are the um, column IDs. You didn't have to write these before, or there was a way for you to not write this. But I had to go back and copy paste all of these, or it was pain. Why didn't I let AI do this? Oh, I did. It came out wrong. There, I wouldn't do it right. I had to do it. Oh. Will it run again? Hmm. Wait a minute. Wait a minute. Oh, it ran everything today. Like, let's hope we don't see the embarrassing error message. This has been really helpful. I learned this from AI basically. You know, when you keep telling them that they're wrong, they do this, and they manually put something in here so you don't realize that they're making mistake. When they don't understand what's going wrong in here in their actual code, they do this and say print everything is fine. They mess with you. AI does this a lot, but this is really helpful. Like you put this try and accept here, and instead of watching a whole lot of errors, it just prints this, and you get this little error, which is really helpful, especially when you're working like this in a Jupyter environment. But this is the whole data set. Why did I want to do it? I made an info. Yeah, 31 columns. God. Copy paste 31 columns. No. Then you have no. Yeah, max supply 45 almost. Non-null and rest was null. Okay, why? No. This makes sense. Image being object. Again, link makes sense. Current price object. Why? Because of the dollar sign. Yeah, I get it. But volume is also an object. Why? Yes, this is weird. Volume is just a number. Maybe like you can't say the price has the dollar sign, and that's why it cannot register it as a integer or a float. But volume is just a number. Why is it an object? Anyway, what did I delete the code. Forget about it. What I do here? Oh, well, I wanted to make a new column. Yeah, sort them based on this. Okay, display sort. Yeah. Okay. Mm-hmm. Um, what do I do next? Mm-hmm. Extract the year from the date and make a new column. Another column price for which is oh, remove the dollar sign. That's what it was. An object like you make the old dollar. Let's see. Mm. Compressed oil supply, old dollar, bunch, yeah. Right. So then what do I do? Old dollar numeric. Have this dollar sign, got rid of the dollar sign. Uh-huh. Cumulative and added the dollar sign back. I wouldn't do this. This is a this one is it. And create the plot. So basically, you use AI when you do this. I recommend you do it. Like you write your code and you give it to AI and let it, make it pretty. And it adds you these stuff, which is really helpful. Really helpful. Like before AI, I couldn't understand what I did, why I did what I did. Like something like this, I couldn't understand what. Whoa, like why would I get rid of the dollar sign? Like why would I do this? Get rid of dollar sign? Oh, but now convert all dollar to numeric for calculation. Then you do the cumulative sum, and then you format it back. You add back the map back the dollar sign. You see, it's really helpful. And let's create a plot, customize the. I wouldn't call it customize it. Just put the show me the plot. Yeah, yeah, yeah. Like, okay, Python is really good at showing you different plots. Like, it's useful when you want to keep looking at how your data ends up looking. You want to see a plot quickly and go make a change and then go back to seeing how your change affected the plot, the shape of your data. This um, this is unmatched. You can do this in Excel, but in Python it's just better for this single use case. But you don't get to get to that point that often. Again, I rarely use a Python for things. When I did, I used it for to gather all the data, make them into a similar shape so I can run SQL on them and analyze them with SQL and Excel. That's the most use case I had from uh, Python. Why did I input NumPy here? Oh, then I click the question. Like model linear regression. Why linear? This is logarithmic. Why linear? Maybe I couldn't make the logarithmic uh, regression work. Yeah, copy paste of all the pre-titles. Edit. If value is this, return value format that calculation. Yeah, this part AI. This part is AI. Like, this is me. This is me. This is me. This is me. 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 Again, still. No, this is me. It didn't work. This is me. It didn't work. AI. This is 40% AI. And the linear regression modeled it for you. So it should have been logarithmic. Oh yeah. And then I wanted to make it logarithmic and I failed miserably. So I let AI do it, which it failed miserably. But it's at least showing something. Mine was affront to humanity. It was out of whack. Like seriously, it wouldn't show anything, or if it did, it would be seriously bad. Anyway, so yeah, we saw the awesome framework in Python. You gather the data, you scrub the data, and you gather it here, scrub it here. And after this, this is just a quick analysis of to see how the data is doing. Scrub it here, played with it here. Again, played with it, found, try to explore it and find a, pattern, and actually saw one, a logarithmic one, and then modeled based off of it. Poorly modeled based off of it. In Excel, you can do it with just one button. It's easy. That's why I keep using Excel. I keep going back to Excel instead of these um, things. It's not a waste of time to learn this, especially like as we keep going on forward, the data is going to keep getting more and more diverse. The databases and your data points keep getting more and more diverse. You have more data entry points and more data overall. So you end up with no other choice but to go Python. This is the reason why I keep exercising more and more with Python. Even though in essence, Python is not made for this. It's a language program and it's risky because while Excel itself cannot corrupt your data, Python definitely can corrupt your data because it's a back end thing. You can absolutely change um, the basic nature of your data in Python, which is, which I shouldn't have to tell you, but it's a really big no. So analytics, if you know your analytics and you're good at it, and you can do math, you become less and less reliant on different tools because you can do better math. So analytics, there's analytics and statistics. There's descriptive statistics, like where you summarize data. Central tendencies, mean, median, and mode. Some things that you, what is it called? Calculate, spread, which is a range and variance and like standard deviation. The other statistics is in inference statistics, inferential statistics, making predictions. You have a hypothesis, you test it, you confirm your assumption, then there's confidence intervals. You estimate true mean of a population using sample data. You have a sample data, you want to expand it to the whole population, and you add a confidence band to it. Then there's probability distributions, like understanding the likelihood of things happening. Like back in, the model that I talked to you about, the Monte Carlo model. This is what you're basically doing. You use normal distribution, binomial, and Poisson distributions, and all these different distributions that you use to understand the model that the data is following. Then there's regression and correlation. Correlation is the strength and direction of a relationship. Is it positively correlated, negatively correlated? Negative correlation would be something that decreases as something increases. This is increasing, this is increasing, and the relationship is decreasing. Positive correlation would be something that increases and the other one increases. This is the type of relationship that they have. Like the demand that you most likely seen the supply demand, and one of them has a positive correlation, the other one has a negative. There's also linear or non-linear regressions and other things. Like when you have 2 points of data, you want to understand what's happening in the middle of it. That's the basis of this. But there are a lot of things that I want to show you, so I'm not talking that much about it. For the final part of our show and tell today, we are looking at some BI. Yeah, this is a very basic BI page. I made it with Google Looker. I have the last Google Data Studio certificate, but they deleted it and they made this Google Looker based on that, and it's not bad, but it's a bit problematic. Especially, it was a bit problematic when it came to formats. Like in here, you see time. The format in this is time. But in here, let me go to edit and show you. The format of time is, you see, what is this? It's text. It's having these no issues. It's not little at all. It's really problematic, and it really gets on your nerves. Seriously, but it's good. It's online. You can simply share it and share it exactly like you would share anything else in the Google workspace, and that's really good. That's for Power BI. You have a little bit of a process, but this is like really easy to share. Make and share it, especially since it's cloud based and you're not running it on your desktop computer and stuff. So what is this? This is a location map because we do have location. Yeah, this is mix. This also has the orders, order count. This is Erie, our island. The order count is here. Mixed, but US is moved through the tectonic plates. Forget about it. You usually have something like this for a basic e-commerce website. This is acceptable, I say. This is your daily total sales, the total, and hours of day. While you need to keep this and save it for yourself so you can then analyze your peak selling time, especially in different seasons. You want to find out like for each country in each season, which is your what is your peak selling time, because you want to know when you have to market yourself, like share a you know people tend to buy at 12 p.m. so share a ad or something before 12. This helps with the planning of marketing stuff. And this is to find your most popular SKUs. It's wrong because database is wrong and we cannot scrub it without uh, seriously messing up the data. This is the countries percentage. You want this live so you can track like at which time which country is most active. Again, it's really good for um, figuring out which country to target at which time. And this scatterplot, it should be your overall, you know, sales per time. You need a scatter plot regardless, all the time. Don't question it. Just have a scatter plot, and then you figure it out. You need a scatter plot. It helps you find out like the odd ones out. You see there's a shape, beautiful shape happening here, and these two are the odd ones. Why? You can go and check them out. But this is wrong because it's based on time, and time here is PM and AM. So they repeat. The 7 in the evening and 7 in the morning, they repeat. No, they shouldn't repeat. This is wrong. And this should be days or months or overall, overall time duration, like since day zero till day 300 or something like that. But we only have data for one day, so this is it. And why did I do this? What is this is to find out the most popular price point. You have the most popular SKU, most popular price point. So, what does this tell me? This tells me that at 12 p.m., my most popular product, which are these three: Queen of the Skies passport cover, Blue Spotty Bowl, and Origami Vanilla or whatever, are mostly sold at United Kingdom, and the price point that they mostly look for is 266 what? But these are $5. Oh, uh-huh. This is total, this is price point. This is something is fishy here. So this is the this tells you like which SKUs to market, to where, to UK, when at 12 p.m. and what's the price point most like most and what's the most popular price point. If we can get, you know, if you want to make a sale or something, an offer or something, you make it at 12 p.m. and you make it in UK and you make it 255 or 295. And you got all that data from a single page. Before this, you had to go and make whole data for this single query, single question. But now, with all these together, you just understood that. Like it was really simple to understand, but it absolutely isn't in real life. It isn't. I made another one too. This one is the old dollar based on the year, and I added a bunch of filters. I couldn't because they had issues, formatting issues. But in here I could, so I added like ID. All the ones that include B cumulatively. For X. Yeah. Also, you can select the data range here. Market cap rank 86 to 100. Let's see how old the top 10 are. We have one at 2017, Another really popular and powerful one in 2020. Another one in 2023. One type 5, type 4, 2013. This is cumulative. This is not, so it's not telling, answering the question that I had. But either way, it's a good thing to have. This one is good. It shows that, the older the crypto is, the more valuable it becomes. So you basically have to keep something for 10 years on average. You buy something, you keep it for 10 years, and it becomes valuable. Based on based on this analysis, the simple analysis, this is what it's telling you. But it's, you know, I told you it's wrong because the all dollar that I made here is not here. Here is this one based on current price. It shouldn't be based on current price. What else do we have here? The last one is a mistake by myself, but what is this? No, not important. The order is like this: select, where, and or division, limit, order by, group by, and this. You see, this is all the syntax, but you cannot put all the syntax of Python or something like that. Absolutely not. Not Python, not pandas, nothing. This SQL is really easy. It's seriously easy. Just play around with it. And you can just do that in Google Sheets. It's easy. Just play around with it. Just go somewhere and just write stuff. Like, let's write a query process right here. Equals query. Let's pick the data. A to H. Select all. It shows me. Now select all that where A equals 0. A is less than 1. There. All the ones without invoice. All the null invoices are shown. Simple. You have to work around it. And you see most of them that don't have invoices are negative. But in here we have negatives that actually have invoices. Okay, let's group by H. Huh. Yeah, just play with it and you'll learn and understand. And if you have a question and like, why did this happen? Like, why when I said group by H and it didn't work, can ask AI. And it can help teach you a lot. Like, while AI might still have real issues when it comes to writing code, and as I told you, it tries to get out of it by lying to you. Like the if with the try and exception thing that I showed you, like it says try this, and if it didn't work, just say, oh, it worked, thumbs up. And it does this sleazy things, but when it comes to SQL, it's good. SQL can be even easier than Excel because you have way less things to work with. You have way less syntaxes to work with than you have functions in Excel. But that's where practice comes in. You have to practice a lot when it comes to SQL. You have to practice to get things. Like you see, I just said A is less than 1 to find out the nulls. Like there might be some other way, but this is the way that I got used to it. And if you didn't know about it, you wouldn't get a good get an answer to your question of which are the orders without invoice. You know, so you need to practice this and just play around with it. The best way to learn Excel and SQL just to play around with them, basically. What else you can learn and makes things really easy is for statistics. Like when you're trying to do statistics, it gets really easy in Excel and Google Sheets and stuff. That it just gives you really good answers and you can track them. Oh, what is this? It shows you it's the average of total. It's really helpful. It really eases things up for you. Okay, that was that. We are finished with our data journey. I had to reference my past videos a lot, and I had to keep telling you that I'm not talking about this, I'm not talking about that. That's for a different video, this is for a different video, because I wanted to cram all the data stuff into one single video. And also I'm using these videos for my portfolio. But again, the project that I had to use in these are the public domain, and I am not doing, they're just really easy projects that I have evolved, But anyway, they were good enough to be easy enough to be shown as an educational thing as well. So I hope you learned something from it. If you have any questions, ask me. Absolutely ask me. I will answer them. And as I said before, I believe that these projects should be done live. So I will do them live, but I don't, as of now, don't have enough of a following to do that. It will be just embarrassing because I need someone to keep asking me stuff. I need, the instant interaction. Otherwise, I'm just working for no reason and no one is, gaining anything from this. So that's that. Even parts of this was live, but I deleted that. Anyway, like, subscribe, comment, and see you later.